1944, a factory floor in Anderson, Indiana. Workers in white uniforms stand at stamping presses, punching sheet metal into shape. Yesterday, these same machines made automobile headlights. Today, they are building submachine guns, 1,000 of them, every 24 hours. The workers are not gunsmiths. They have never built a weapon in their lives, and the gun rolling off their assembly line cost less than $21. It will serve American soldiers for the next 50 years. This is the story of the M3 submachine gun. Soldiers called it the grease gun because it looked like something a mechanic would use to lubricate a truck. They also called it the plumber's nightmare, the cake decorator, a piece of junk. The army called it something else entirely. They called it disposable. When it broke, you were supposed to throw it away and draw a new one, but nobody told the enemy that. To understand why the American military deliberately designed a weapon meant to be thrown in the trash, you have to understand the Thompson submachine gun and the problem it created. The Thompson was magnificent. Soldiers loved it. The press loved it. Hollywood loved it. And that was precisely the problem. In 1939, a single Thompson M1928A1 cost $209. Adjusted for today, that is roughly $3,500. 4 months of a private's wages for one weapon. The Thompson required extensive precision machining, skilled labor, and more than 100 individual parts. When America entered the war after Pearl Harbor, the military needed submachine guns by the hundreds of thousands. The Thompson could not be built fast enough, but the bottleneck was not labor. It was not even money. It was machine tools. Every precision milling machine dedicated to Thompson production was a machine that could not produce something else. Aircraft parts, tank components, artillery pieces. The Thompson was consuming industrial capacity America could not afford to spend. Colonel René Studler, Chief of Small Arms Research and Development, had been watching the enemy. In late 1940, he obtained a captured German MP-40 for examination. The Germans had solved the production problem years earlier. Their submachine gun used stamped sheet metal instead of machined parts. It could be built by workers with minimal training on equipment found in any automobile factory. Studler wanted the same capability for America, but he wanted it cheaper. He wanted it simpler. He wanted a weapon so inexpensive that if a soldier's gun jammed in the middle of a firefight, he could throw it away, pick up a rifle from a fallen comrade, and keep fighting. The army did not need a masterpiece. The army needed a tool, something that worked well enough, cost almost nothing, and could be manufactured by the millions. In October 1942, Studler found the man who could build it, and that man had learned his trade designing weapons for the enemy. George Hyde was born Georg Hyde in Opfingen, Germany, in 1888. He designed weapons for the Kaiser's army during the First World War. In 1926, he emigrated to America, anglicized his name, and spent the next 15 years trying to sell the United States military on his submachine gun designs. They rejected him repeatedly. Now, with the nation at war, they finally listened. Hyde's design philosophy was brutal in its simplicity. He looked at the Thompson and asked a single question about every component. Does the soldier actually need this? If the answer was no, he cut it. The Thompson had adjustable sights calibrated for different ranges. Hyde gave the M3 a single fixed aperture set at 100 yards, close enough for the distances submachine guns actually engaged targets. The Thompson offered select fire, allowing soldiers to choose between semi-automatic and fully automatic. Hyde eliminated the option entirely. The M3 fired full auto only, one less mechanism to manufacture, one less thing to break. The Thompson used finely machined components fitted to tight tolerances. Hyde designed his receiver from 2 stamped sheet metal halves welded together. The entire weapon contained only 73 parts. Only 2 of them, the bolt and the barrel, required precision machining. Everything else could be stamped out by workers who had never touched a firearm. But Hyde's true genius was the dual guide rod system. In a conventional submachine gun, the bolt must fit precisely within the receiver. Loose tolerances cause jams. Hyde mounted his bolt on 2 parallel recoil spring guide rods. The bolt floated between them, never touching the receiver walls. Dirt, sand, mud, it did not matter. The debris fell into the gap between the bolt and receiver, where it could not interfere with the action. When the Army tested the M3 at Aberdeen Proving Ground, it proved more reliable in adverse conditions than any American submachine gun ever evaluated. The slow rate of fire was deliberate. The Thompson cycled at 600 to 700 rounds per minute. Hyde's M3 fired only 450. He achieved this through a heavy bolt and lighter compression springs. Soldiers complained the gun sounded anemic. What they discovered in combat was different. The slower cycle meant less muzzle climb, easier to control, easier to keep rounds on target, and ammunition lasted longer. A soldier could stay in the fight when others had emptied their magazines. The final specification bordered on absurd. Hyde designed the wire buttstock to serve as a toolkit. Both ends were tapped and drilled. One worked as a cleaning rod, the other as a wrench for the barrel nut. The stock itself functioned as a magazine loading tool. Every component served multiple purposes. Nothing was wasted. The complete weapon weighed just over 8 pounds empty. 2.5 pounds lighter than the Thompson. Collapsed for transport, it measured less than 22 inches. Small enough to fit inside a tank turret. Small enough for a paratrooper to jump with it ready to fire. Now Hyde needed someone to build it, and the army had the perfect candidate, a factory full of workers who had never made a gun in their lives. The contract went to Guide Lamp Division, a General Motors subsidiary in Anderson, Indiana. Their specialty was automobile headlights. Their workers knew how to stamp sheet metal at industrial scale. They knew nothing about weapons. The army considered this an advantage. Guide Lamp had already proven what untrained workers could accomplish. In the summer of 1942, 300 women working in a walled-off section of the plant produced 1 million FP45 Liberator pistols in just 11 weeks. One single-shot pistol every 6.6 seconds. Both the Liberator and the M3 were George Hyde designs. Both were intended to be thrown away when they broke. The M3 was officially adopted on December 24, 1942. By July 1943, only 900 had been built. The first production run nearly killed the entire program. Guide lamp workers, accustomed to headlight assembly, applied too much heat when welding the receiver halves together. The metal warped. The bolts would not cycle. Nearly 20,000 guns were rejected. The engineers adjusted. Production accelerated. By 1944, Guide Lamp was manufacturing 1,000 M3 submachine guns every 24 hours. The final cost came to $20.94 per unit, $18.36 for the receiver, $2.58 for the bolt, 1/10 the price of a Thompson. If you are finding this deep dive interesting, consider subscribing. It costs nothing, takes a second, and helps the channel continue. Now back to Normandy. June 6, 1944. Paratroopers of the 82nd and 101st Airborne Divisions jumped into France carrying America's new submachine gun into combat for the first time. Private Don Burgett of the 101st called it a piece of junk. He was not alone. Soldiers held the weapon in mild contempt. They called it a cheap knockoff of the German MP-40. Then combat happened. Technical Sergeant Charles Carey of the 397th Infantry Regiment carried an M3 into Rimling, France, on January 8, 1945. When German forces launched a pre-dawn attack, Carey assembled a squad and counterattacked. He moved from building to building, firing bursts through doorways, demanding surrender in a voice loud enough to carry over gunfire. Witnesses watched him step in front of occupied houses, empty his magazine, and shout for the Germans to come out. By the time enemy fire finally killed him, Carey had captured approximately 70 prisoners, rescued an anti-tank crew and destroyed a German tank. He received the Medal of Honor. The piece of junk had proven what it could do, but it still had problems the army refused to fix. The M3's most notorious flaw was the cocking handle. A side-mounted lever retracted the bolt before firing. The mechanism used low-grade steel with improper heat treatment. Drop an M3 the wrong way, bump it against a wall, and the handle could shear off completely. Reports flooded in from France after D-Day. Soldiers had broken guns and no way to fix them. The army had stocked no replacement parts. The weapon was disposable. They had not planned for repairs. The magazines caused constant problems. Stiff springs made them difficult to load without a special tool. The feed lips bent easily, causing jams. Test boards from 4 different army branches documented the defects during initial trials. No changes were ever made because so many magazines had already been manufactured. Yet here is what these failures actually proved. The M3 was so cheap that even when pieces broke, even when magazines failed, the army could simply issue more guns. A soldier whose Thompson went down waited weeks for parts from the depot. A soldier whose M3 went down drew another one from supply that afternoon. The limitations were not flaws in the design. They were features of the doctrine. Disposability was the point. The Soviets tested a captured M3 in May of 1944. Their assessment surprised everyone. The Red Army's scientific research proving grounds, builders of the excellent PPS-43, concluded that the crude American weapon matched the best submachine guns in the world. They specifically praised its dust resistance and jam-free operation under difficult conditions. The Americans had built something ugly, cheap, and undeniably effective. The M3A1 arrived in December 1944 with a solution to the cocking handle problem that bordered on absurd. Hyde eliminated the entire mechanism, all 9 parts, gone. In their place, he machined a finger-sized hole into the bolt face. Soldiers retracted the bolt by sticking their finger through the ejection port and pulling. It looked ridiculous. It worked perfectly. The M3A1 weighed 3 ounces less than the original and had fewer parts to break. The Thompson left frontline service shortly after the war. The disposable M3 kept going. Tank crews carried them in M48 Pattons, M60 main battle tanks, and M551 Sheridans. The weapon designed to be thrown away served for 50 years. The 73rd Cavalry Regiment finally turned in their M3A1s in 1996, along with their Sheridans. Today, if you visit Anderson, Indiana, you will not find the guide lamp plant. General Motors closed it decades ago. The workers who built 1,000 submachine guns a day have passed into history. But their weapons survive in museums across the country, testifying to a moment when America decided that elegance did not matter. Only results. The Thompson was a masterpiece of precision machining. The grease gun was a masterpiece of industrial logic. In 1944, when paratroopers jumped into Normandy with $20 stamped metal tubes in their hands, they carried the future of American weapons design. Cheap, reliable, replaceable. The gun nobody loved. The gun that worked. What do you think? Was the M3's disposable philosophy the right approach for a nation fighting a global war? Or did the Army sacrifice too much by abandoning the craftsmanship of weapons like the Thompson? I would love